So here, as you can see, for annotating textual description, we used active learning technique. At first, we had to get some annotations for the labels we have. So we got the help of domain experts for detecting the mention of the color. So here, for example, we see textual description example, and here we have the mention of the color blue, and we want to know what the meaning of this color blue mean, whether it's for example, background color, represent background color, foreground color, or border color, or some other color, or some irrelevance. So for this one, we use we use it just for reference and understanding the data, so we can progress to the next level, which is basically once we got some statistic, we realized, for example, here that foreground color is the most promising label to have, mainly because if we have more data about it. So for that we prepared another interface, so where the annotators have example with the same similar color annotated here. And here the annotator has to answer whether this color represents a foreground color or not. So it's not, before it was more multiple choice based on the label, whereas here we have only yes no question. So for the foreground, we did some experiments and we got the following. So we got we got precision of 64 and F1 of 78.4%. We did a similar experiment with also the number of section. So instead of color as the entity, we have the number as entity, and we are predicting whether this number represents the number of section or not. And we got a precision of around 60% and accuracy around 57%. Okay, this is the data. Yeah, so here just to give some statistic about the data set that we used, here, so you can see for foreground colors we have around, for foreground colors here, we have around 200 items for testing. And during the process of active learning, we labeled around 100 items. Whereas for the test data, we have around, for the number of sections, we have around 139, around 140 items for the test, and we have 63 labeled during the active learning. We also use, so after the active learning is done, we also try to use some supervised methods based on the labels that we are obtained throughout the active learning, so basically those. And we try to use different classifiers. So before that was done on using the linear SVM for the classifier, whereas here we use some other ones. So for example, here we use random forest. We got those. We used XGBoost, which is basically gradient boosting decision trees, and we got relatively different results, but sometimes more balanced here. So basically now we will see a demo how the system is work. Where is it? Here. Here. Oh, okay. Okay, so here, for example, here this is what it looks like from the perspective of the annotator. So he has here a number of tasks and select. So for example, here we can select for the number task that we talked about for the number task. So here, when you double click, you see how the interface looks like. So here, for example, we're detecting whether the number selected, we have textual field here, and then we have a number entity selected, and whether this number represents number of yarns, dimension, or section, and so on. So whenever you click, you move to the next example, and you can see each one of them. And once you're done, you can skip or so on. Once you're done, you can save and exit. But since I'm labeling them wrong, I'm just gonna exit here. This was for the multiple choice. For example, when we want to have the active learning, we can choose here, for example, number of sections. We have the other interface where we have where we have like also a similar text with the entity name labeled here, whether this is yes or no, whether this is the present number of section or not. And whenever we have one iteration of labeling, after the end of the iteration, we have the classifier is run again on the new data and to get the next iteration for the active learning. So yeah.